Hello, today we have a shortest, safest path in a matrix. So you given the index to the matrix, n by n represent empty cell, your initial cell. Position 0, 0 in the move, you can move to any adjusted cell as a grid, including cells containing thieves. Safe factor of the path minimum Manhattan distance from any cell in a path of any thief in the grid. Returns the maximum safeness factor to all adjusted within cell. An adjusted cell Manhattan distance, okay, and now so because we have 1, we start from 0, 0 to n, we have 0, so result is 0. Here we have 2 because we have 1, 2 distance. Okay, here we have a 3 because 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay. 0, 0, 1, 2, 3. 0, 1, 2. Okay, here is 2. Result is 2. Okay, so result is 2 because 1, 2. Yeah. Okay, so I think we have to, what we have to do, we have to create a safety matrix. Let's call it SM, and it will be size n by n. And we iterate original matrix, iterate grid, and if grid x, y equal n, then we BFS we BFS xy, and this will update safety matrix. So this is second step. Third step, we start from safety matrix 0, 0, right? And then we decide our next move based on data into safe distance with distance from xy. Okay, so DFS will be a recurrent function, so we call for n next as a 1, next as a 1, and there is a 1 problem here. So what if we have already values in to safety matrix from other thieves? We have a distance, let's call it distance from other thief. We are interested into a minimum, right? So we should have a max. We should have a mean distance. We should, if SM x y is so inside of BFS, right? So as we defined BFS XY0 and XY and D distance, right? And if we already have a value from different thief, right? Then less than D, we update only if then we assign D. Okay, so then we create SM with infinite amounts in it. So by default we have a infinite distance, right? To it. Okay, and we move to we select and we select next. Next down or right based on SM based on we select next down or right based on values into safety matrix. And yeah, until we reach right. So this is our first step. Okay, so in this case, time complexity will be n by n, and space complexity also will be n by n. Do we have any restrictions on time and space complexity? No, grid length is 400, which is accessible for that. Okay, let's go and implement it. So first, what we're gonna do, we create so value can be 0 or 1. Okay, so we create first we find n, right? We need n, which is line of grid. Then we define the safety matrix, which is ENF float ENF multiplied, which is maximum infinity, right? Multiplied by n for E in range And so we have safety matrix here. Then for for x in range n, then for y in range n, if x if grid s and m equal 1, we call DFS or BFS SM0 or wait, X, Y, we call X and Y and 0. So this is our first step. We update distance. This is our first, this is our second, this is our third step, right? We must define the first function x, y, distance. So we start from x, y, then we call for next cell, right? We can go down, up, but if thief is located here, right, we have to calculate or for function, right? And then call like all explore entire thing. So what we're gonna do, we're gonna if safety matrix x, y more than d, we assign it. So we found less distance. We also call BFS for x plus 1, x plus 1, no, x plus 1, then x minus 1, then y plus 1, y minus 1, and we have d plus 1, d plus 1, d plus 1, d plus 1. And we also have to check if x more or equal n, or y more than equal n, then we just return. So we don't have to check it, but yeah. And then we call the FS. I just want to print SM matrix here, just to make sure. Okay, yes, so there is a mistake here. I have to do like this. Great, right here. No. Okay, why I have maximum execution? My god. Okay, so n is a length of grid. Then I do call xy for xy and bfs xy 0. So if okay, let's print xy. I don't know why it's cycling. I have no idea. But let's check it. If x more or equal n. So 0, 0, 1, 0, 2, 0, 3, 0, 1, 0, 2, 0. Oh, it's going back and forward. I have to visit it. Oh, gee. Okay, visit matrix. For the specific, let's define visited, which is here. Similar like this, but is false. And we defined new matrix here, and we call BFS, right? And we add visited x, y equal false, or visited x, y, we return, right? We return, then we assign true right away. Okay. This is not this slice is not typo. Yes, of course. And so indices. Okay, so we have a 650741. Okay, right, so large. We have to have smaller. Do we? If d less than what we have, then we assign d. Okay. Hmm. Zero, 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 one, zero, two. But how it's 1, 2, 3, 4, 5? Max is 5, 6, 7, 8. Okay. Oh, okay. Now I understand. So if we go 0, 1, 2. 6, 5, 0. Why that? Because this is small, so we have a 0. Oh, 0, 0, 1. It's a different example. This is this example 0, 0, 1, 0, 0, 0, 0, 1, 0. So we have 6. 1, 2, 1, 2, 3, 4, 5, 6, but it's not direct. So we have to do like wave algorithm. So this is 1, all this 2, this is 3. Yeah. We cannot do BFS. It's not BFS per se. This is more like DFS. This is why we have all the same. But to do BFS, breadth first search, we have to do like first layer, second layer. Or like if it's in the middle, we have to do like first layer, second layer. Can we do get bigger matrix like here? Then all around 1, 2, 3, 4 gets 1. And then okay, that's too much. Yeah, I'm out of time at this point. But yeah, it's more complex and requires more time to, to develop it. Alright, that's it for today. Thank you for watching.